Hi friends, welcome to Taming Python series. In this video, we're going to talk about advanced data frame rows filtering with lambda functions. In our previous video, we have seen how to do data frame rows filtering with simple conditional statements. There might be some use cases where your filtering logic may be complex and your filtering logic may involve more than one column. DataFrame.apply can help you in that. So let's take an example. It's a small example which I have demonstrated in this post. I will give the link of this post. I will also give the link of the CSV file which I have used for this demonstration of this example. So you can see that in the description of this video. Let's come to the example. Here I've got a data frame called df and I've got it from a CSV file. While writing the condition inside data frame square brackets, here what I'm doing is I'm creating a new series by using df.apply, and there I'm giving a lambda function. So what lambda function is it's basically a single line function. So lambda function is really simple. You take a input and after colon you just return something and it will be the result of that lambda function. So when you write df.apply and axis equal to 1, what happens is that every row will be passed into lambda function as a series, and you can do whatever with it and return from this lambda function. And in our case, what we are doing is that we are comparing, VSTPS 3 column of that series with VSTPS 4 column, and we are doing greater than. So what happens is that the result is a true or false. So ultimately what we are doing is that when we are doing df.apply on each row, then what happens is that you will be returned with a series of trues and false. And remember, in our last video we already told, if you just give a list of trues and false inside a data frame square brackets, they will act as row selectors. So this is the logic behind using apply for advanced row filtering. And why is it advanced? Because when you give x is a row, and you can apply whatever logic you want to qualify this row. So the flexibility you get to qualify the rows is very good in case of lambda functions. So let's get started with the example now. I'm taking a blank folder and I have pasted this CSV file. I will mention the link of the CSV file in the description of this video, so you can download it there. So I've kept the CSV file in the folder, and now I'll open it with VS Code. Alright, my VS Code is now open. Now I'll create a new Python file. I'll just name it index.py, and then now I'll import pandas as PD, and I'll even import my CSV file. I need some data, right? pd.read csv, and here I'll write the path of that file, and the file name is gen_schedule.exe. I'll just copy this and I'll paste the file name here .csv, and I'll just print the data frame for you, and now I'll just run it. You can see this is the data frame. You can see the data frame here. So it looks something like this. Alright, it has a lot of columns. Okay, so this is the data frame, right? Now I want to filter this data frame. So okay, now before filtering, I'll just show you what is df.apply. What does df.apply do? So I'll create a new variable called x, and x equal to, I'll write df.apply, and here give the first argument as a lambda function. So I'll write lambda, and here I'll write something like t, and now the t which is given to the lambda function is the row. So for each row you'll get a chance to run this lambda function, right? You can do like t of something like take a row. I'll just take this column, something like greater than 500. Okay, this was the lambda function. I'll write axis equal to 1. If you write axis equal to 1, that means you are doing this lambda operation for each row. If you write axis equal to 0, you will do the lambda operation on each column. I want to do it for each row, so I'll write axis equal to 1. I just instead of doing this, I'll just do this thing only. That means for each row I'm returning the value of the column VSTPS 3. So let's see what happens. I'll just print x. So now what I did was I used the apply function, and I'm doing it on axis equal to 1. That means I'm applying some function on each row, and then I'm giving a lambda function. What lambda function does is that it will pass the row as a series, and it will expect something in return. So what I'm doing is that I'm giving the value of VSTPS 3 column from that series in return. So what should I get is I should get the column value of VSTPS3 in each item of the series inside a series name called X. So let me try to save it and run this. You can see what happened is that I've got the value of VSTPS3 only. Now if you want to do VSTPS3 plus something, some other row, some other column name. Suppose I want to use the column name CGPL. There is this column in this data frame. You can see there is this column called CGPL, right? So I'm using that column. So what I'm doing is that for each row, I'm adding this one plus this one, right? VSTPS3 and CGPL. Let me run this. You can see I've added two columns and I've given it here. That means what apply does is that it will create a new column data for you. Now we can exploit this behavior to create a series of trues and false. So let me try to demonstrate what I'm telling. I'll just write T of VSTPS3 greater than T of VSTPS4. So there are two columns VSTPS3 and VSTPS4 inside this CSV file. So what I'm doing is that for each row, while iterating through each row, what I'm doing is that I'm checking a condition whether T of VSTPS3 greater than T of VSTPS4. So what the answer would be is just true and false. So X should be a series with trues and false as output. So let me try to run this. And now you can see I've got trues and false. That means what happening is that by using df.apply, I'm iterating through each row and I'm deriving some condition on it. In my case, I'm deriving whether VSTPS3 is greater than 4 or not. So this can be my condition to create a series of trues and false. Even in the previous video, I told you that you just need a series of trues and false to filter a data frame. So I can use this condition to filter this data frame. So if I write df2 equal to df of x, then what happens is that I am passing a list of trues and falses inside this data frame, and these will act as row selectors. Okay, so let me try to create a data frame called df2 as df of x, and I'm trying to print that. So let me see what happens. Actually, I got only 34 rows. You can see I got only 34 rows. That means only 34 rows have satisfied this condition. You know, if you want, you can even print the lengths. I'll just write print df dot shape, and I'll print df2 dot shape again. So let me try to run this. Here you can see df shape was 141, that means 100 rows 41 columns, and df2 is 34 rows 41 columns. That means I've successfully applied a filtering criteria using the lambda function, and then I'm using that filtering criteria to filter this data frame. So you can see if your filtering criteria is something more complex that involves more than one column, or that involves some completely different filtering criteria altogether, then you can use this apply function to create a custom filtering function, and you can create a series of out of that and pass it to the data frame to create a new data frame that is a filtered data frame. You know, I've used X. I don't need to do that. I just cut this, and I can paste this here, and that's it. I can write df.apply and all my criteria inside this lambda function and pass the access. So that's it, guys. It's really simple. This is how you can use the data frame apply function to do advanced filtering of data frame rows. You can see I've created a post on this topic, advanced data frame filtering using lambda functions, and I also given the example which I've demonstrated here, and there is also a link to the CSV file in this post. You can download it from here. So be sure to check out the link of this post in the description of this video. That's it, guys. Hope you like this video. Thank you for watching.